So next in this discussion we are going to see another standard limit proof. So what is the next standard limit? Limit x tends to 0, a power x minus 1 by x is equals to log a base e. So here if you observe this log, okay, here the base is e. So if a logarithm whose base is e, such logarithms are called natural logarithms. So we can represent these natural logarithms as ln. L represents log, n represents natural. Natural means the base of the logarithm is e. Okay, a is an argument, so we can write ln a. So log a base e can also be written as what? Ln a. So now we'll see the proof of this one. So how to find the proof, or what is the way we can prove this? See, in the last class or in the last discussion, we have seen the exponential series e power x. So e power x is equals to what? E power x is equals to 1 plus, okay, x power 1 by 1 factorial plus x power 2 by 2 factorial plus x power 3 by 3 factorial and so on. Okay. So 1 plus x power 1 by 1 factorial, x power 2 by 2 factorial, x power 3 by 3 factorial and so on. So this series will continue. Continue means it continues till infinite. So this is the value of e power x. Now there is a relationship between this e and this a power x. See, in the last class we also see what is e and what is the e power x. Okay. See, now in logarithms we have these kind of formula. For example, a power of log of base a whose power is log and whose logarithmic base is a, n. Okay, so a power logarithm of n to the base a is equals to n. Okay, whenever these two are equal, then this argument is going to become the answer. For example, in same way, if I write a power log a base n power something like, okay, n power m, we can write as what? So if these two are equal, then this is going to be n power m. So this is how we can write. So this is this formula we are going to help, or this formula we are going to use to write a power x also. See, a power x, I would like to write a power x as in terms of e. So to write that, what I am going to use is, so I would like to write this as e power logarithm of base e, and here I would like to write a power x. Now if you observe this, okay, here these two are same. Whenever these two are same, then what is the answer? A power x. So a power x I can write as what? E whose power is logarithm and whose base is a and argument is a power x. So we can write a power x as e power log a power x to the base a. Okay, and this also can be written as, see, what I am trying to do is I would like to express a power x value as e power x. Now if you observe here, your a power x is expressing or representing in terms of e power x. So this value is what? Is it not looking like e and this is x? Is it not looking like e power x? So we can write a power x series also with the help of e power x. Okay, now here I can just simplify another way. I can simplify a little further. That is how. See, we have one formula in logarithms. What is that? Log for example, m whose power is n and base is something called a. So we can write this as what? N into log m base a. So this is how we can write. Same as that, this x will come to this side. So here it will become x into log a base e. So now x log a base e is just acting like e power x. Okay, so this is acting as x. But this value I would just, okay, I would like to assume as y. Okay, instead of x, I would like to assume this value as y. So if I assume this value as y, so it's just looking like e power y. So y is nothing but what? X into log a base e. So now here if I substitute, what are you going to get? E power, okay. Now I would like to write e power y formula. So how it is going to be? 1 plus, so x plus what we need to write? X is nothing but y here. So here this x is nothing but this y. So what we can write here? X plus, I can write x into logarithm of e, logarithm of a to the base e by 1 factorial. So 1 factorial we can simply write it as what? 1. So I am not writing 1. Okay, if you want, let us write 1 factorial for the first step. Next, plus x square. So this is x square. X square means here y. In place of this, it is y. So what we can write? X into, okay, log a base e whole power, okay, x plus what we need to write? This value, whole power 2 by 2 factorial, okay, plus into x into, so this one, x into log a base e whole power 3 by 3 factorial and so on. So this is how we can expand this value. So here y is nothing but what? Y is nothing but this value. Okay. So if I write y, if I replace this y, what is going to happen? What will write in place of e, in place of y? So it is going to be x into logarithm of a base e. This is nothing but what? A power x, because these two are going to be 1. So indirectly this e power y is nothing but what? Okay, this is actually the expansion or expansion form of, or the expanded form of what? A power x. So this is the a power x value. So what is a power x value? 1 plus x into log a base e by 1 factorial plus x into log a base e whole power 2 square, this square by 2 factorial and so on. So same thing we are going to substitute here. So if I substitute here, what are you going to get? So let me substitute here. So limit x tends to 0. So in place of a power x, so this is the a power x value, this entire thing. That is the a power x value. So if I substitute here, 1 plus x into log a base e by 1 factorial plus x into log a base e whole power 2 by 2 factorial x into log base a e whole power 3 by 3 factorial and so on. So this is a power x place. Next we have minus 1 plus, lastly we have minus 1. So this plus 1 and minus 1 gets cancelled by, we have x also, x. So now what we can write? Limit x tends to 0. Okay, so this is the value. So now for example, if something is in the form of a by b by c, we can write as what? A by b into c. So this x will come here. So x into logarithm of base a e, okay, 1 factorial into x, or x into 1 factorial, both are same. Here we'll get like x power 2 into logarithm of a base e whole power 2 by 2 factorial into x plus x cube into logarithm of, see this power we are applying to this, x cube into logarithm of a base e whole power 3 by 3 factorial into x, and so on. Now this x and x gets cancelled, this also gets cancelled, this also gets cancelled. So now what I am going to do, I am going to substitute this limit, I am going to apply this limit to everything. So if I apply limit to this one, this is actually log a base e. It is a constant. E is a constant. A is also some kind of number. Okay. So therefore that is going to be a constant, and we cannot apply the logarithms or limits to a constant. So I am writing log a base e without applying a limit. But this limit can be applied to this one. So limit x tends to 0. Okay, here what are you going to get? This x and x gets cancelled. Now you will have x into logarithm of a base e whole power 2 by 2 factorial, and limit x tends to 0, x into log a base e whole power 3 by, see this is actually x square because 1x gets cancelled, by 3 factorial, and so on. So if you apply x value 0, so 0 into some log, it is going to become 0. So this value is going to become 0. Here x square, if I apply, if I substitute x value 0, this is also going to become 0. So in every place you are going to get 0. So what is the final way? What is the final term which is missing? Which is leaving logarithm of a base e. So therefore logarithm of a base e. So this is how we can prove this one. So that's all about this one.